Worked example 4, fundamental quantities, question 1. Determine the total charge moved in a circuit if the current was 5 amps for 10 seconds. So it's telling us that our current is 5 amps and the time is 10 seconds. We're trying to work out the amount of charge, Q. So the formula that comes to mind when we have these three terms is Q equals IT. So we can substitute our values in here, 5 times 10 seconds, and we get a charge of 50 coulombs. Question 2. Calculate the energy available in a battery if the voltage is 12 volts and its stored charge is 6,000 coulombs. So the voltage we've got is 12 volts and the charge is stored in it is 6,000 coulombs. And we're asked to work out the amount of energy that is available inside that battery. Well, E equals Q, or E equals QV, or E equals VQ tells us the amount of energy available based on the voltage and the amount of charge in there. So we can take our charge of 6,000 coulombs and multiply it by our voltage of 12, and that gives us 72,000 joules, or 72 kilojoules. Question 3. Calculate how much energy a 1 kilowatt heater has used if it has been running for 1 hour. So the power of our 1 kilowatt heater has been used for an hour. Now straight away, usually we want to calculate in seconds here. So what I would do is I would convert that hour into seconds. So every hour has 60 minutes and every minute has 60 seconds. So basically 60 times 60, and that's 3,600 seconds. To get the total amount of energy used, consumed, or converted if you like, our energy is equal to our power times time, E equals PT. So we can go ahead and substitute our values in here of our power of 1,000 watts multiplied by our time of 3,600. And that gives us a grand total of 3,600,000 joules, or 3.6 megajoules. Question 4. Determine the power of a light bulb if it has a voltage of 230 volts and is drawing 0.435 amps. So our current draw is 0.435 amps and the supply voltage is 230 volts, which is our standard supply voltage in the UK. So it's asking us for our power. So P, straightforward enough, is IV. Power is current times voltage. So our current is 0.435 multiplied by 230, which in this case is 100.05 watts. Basically, on this one, we can take that as being 100 watts. So if we had a 100 watt light bulb connected to a 230 volt supply, we would be expecting to draw 0.435 amps of current. Question 5. Determine the voltage drop over a component if the current is 2 amps, so our current is 2 amps, and it has a resistance of 40 ohms. Well, we're being asked for the voltage drop here, and we've got I and R, so this takes us to Ohm's law, which is V equals IR. In this case, our current is 2, our resistance is 40, so we've got 2 times 40, which is 80 volts.